this video I'm going to be talking about 2.6, rational functions. Don't forget rational functions, our parent is y equals 1 over x, which looks similar to this. Okay, so hopefully all of our pictures will look something like that. They won't necessarily look like that, but it'll be something to that. Okay, we have this vertical asymptote. A vertical asymptote is when the denominators are set equal to 0. So if we have something, say, over x plus 3, then x equals negative 3 would be our vertical asymptote. And we could have the asymptote now at negative 3. We cannot cross that line. Horizontal asymptotes are a little bit weird. There's not really a whole ton of rhyme or reason, but there are rules that we have to follow. I can talk to you guys later about why, when, how, who, what, where, and all that good stuff, and how we came up with horizontal asymptotes. But for this video's purposes, I'm just going to say our rules are these. So if you want to pause the video, write some stuff down. The leading coefficient on top is higher than the bottom. What that means is I'm talking about the degree. So if I have 3x cubed over 2x squared, then there is no horizontal asymptote to draw. If the leading coefficient degree on top is the same as the bottom, as in this case where I have 3x squared over 2x squared, then the leading coefficient over the leading coefficient is your horizontal asymptote. So in this case we have 3 over 2, so there's our horizontal asymptote, y equals 3 over 2. If the leading coefficient degree on top is lower than the one on bottom, so if I had 3x over 2x squared, the one on top is lower than the one on bottom, y equals 0 is our horizontal asymptote, as is the case with our parent function. Y equals 0 is our horizontal asymptote. Also, in order to graph these things, to make your life simple, orders 1 through 6 don't really matter. Oh, sorry, I lied. Even though I'm sitting down. Oh, what is this? Orders 2 through 6 don't really matter which order you do them in. That's just the order that I always do them in, just so that I keep it straight and I keep it consistent. You always, though, have to simplify if possible first. That could be factoring things out, seeing if things cancel out by factoring them. Different things will happen in the simplifying process. Then you're going to plot f of 0. Don't forget, this is just your y-intercept. Find the 0 as the numerator, which is the top, and that will be our x-intercepts. Find the 0 as the denominator. Don't forget that that is just your vertical asymptotes. Find and sketch the horizontal asymptotes. Plot extra points if we need to. We like to have at least 2 on each side. Sometimes things happen weird with horizontal asymptotes and we may cross them. And then just draw smooth curves to connect your points. Now I'm going to look at a few examples of graphing these actual rational functions. So for this one we have f of x equals 1 over x minus 3. Our first step was to simplify if possible. Nothing really simplifies, there's nothing to factor or anything really to do. So cool, we're done with that step. Next step was to plot f of 0. Well, if I find f of 0, that's when I plug in 0 for x. So if I put in a 0, I have 1 over negative 3, so f of 0 equals negative 1/3. And I can go ahead and plot it, so 0, negative 1/3 is somewhere in there. Step 3 was find the zeros of the top of our equation. Those are our x-intercepts. Well, since there isn't really a function or anything on top other than 1, there are no zeros, so there are no x-intercepts. Find the zeros of the bottom, which are our vertical asymptotes. So since I can just take the bottom and find the 0, so x minus 3, I'm setting the entire bottom 0, so that I know my vertical asymptote, the thing that I cannot touch is x equals 3. So at 3, I'm just going to make a dotted line. Sorry, it's not very good, but it's supposed to be a straight dotted line. Yeah, that was a better side. Okay, so there's our vertical asymptote. Step 5 is to find our horizontal asymptote. These are the rules. Okay, in this case, the degree on top, there's not even an x, so it's like 0. So the degree on top is lower than the degree on bottom. Therefore, my asymptote is y equals 0. That's my horizontal asymptote. So at 0, this is the thing that I cannot touch, which makes sense why this would be 1/3 and there are no x-intercepts. And now 6, plot extra points. I don't really know exactly what happens on this side of my vertical asymptote. It's probably going to go down, but I don't really know. So I'm going to see what happens on the 2. So I'm just going to make a little table, help myself out. If I plug in 2, 1 over 2 minus 3, 2 minus 3 is negative 1, so 1 divided by negative 1 is negative 1, so I have 2, negative 1, and it does look like this is going to keep getting closer and closer to that asymptote as it goes, and then I'm going to have to cross through 2 and keep getting closer there. So cool, that side's done. But I don't know on this side if I'm supposed to be down here or up here, so I'm going to pick 4 and say 6. So if I choose 4, 1 over 4 minus 3 is 1 over 1, which is 1. And if I choose 6, 1 over 6 minus 3 is 1/3. So 6 and 1/3. So it looks like they're going to be on top. So I have 4, 1 and 6, 1/3. So it looks like it's going to kind of mirror it over the new origin type thing. And that's your graph. Okay, if we wanted to do, say we want to know the domain, and we want to know if this thing is continuous. You also want to know what the intercepts are. That includes both y and the x-axis. Last thing that it'll ask you for is the vertical asymptote and the horizontal asymptote, which really we've already found. Right, that's those two things right there. So for the domain, it's just all the x values included. So it looks like all of these are included, and then I get to 3, and I can't have 3 because I have a vertical asymptote there. And then from 3 on, it's included. So from negative infinity all the way up to 3, but 3 is not included, and 3 to infinity are all a part of my domain. Is it continuous? Well, on graphing, did I have to lift up my pencil to continue to draw it? Yes. So, no, this thing is not continuous. For my intercepts, my y-intercept is 0, 1/3. Sorry, 0, negative 1/3. And for my x-intercept, I never cross the x-axis because of that horizontal asymptote, so there are none. Don't write 0. 0 is a number. 0 tells me something. Just write the word none, or there are no x-intercepts, or something to that effect. Our vertical asymptote we have is x equals 3. Our horizontal we have as y equals 0. Good to go. Happy day. Looking at another example, we have 1 minus 3x over 1 minus x. Again, our first step is to simplify, but do not try to simplify these x's. There's not an x in both terms, so this thing does not simplify at all. So, cool, we're done with simplifying. My step 2 was find f of 0. Well, if I put in 0 here and 0 here, then I just have 1. So I have the point 0, 1. So I'm going to cross my y-axis right there. Step 3 was to find the zeros of the top. So I have the zeros on top is 1 minus 3x equals 0. So x will be, let's see, 1/3. So you move it over, make negative 1, divide by negative 3. We'll make this a positive 1/3. Work it out if you don't believe me. Sorry, that sounded mean. It didn't mean to be. Try to work it out if you're really confused about it. Okay, so I have the point x equals 1/3, and I cross that about right there. So I know I'm going to have an x-intercept. So if you want to, go ahead and write your intercepts. Y-intercept is 0, 1. X-intercept is 1/3, 0. Bueno. Step 4 is to find the zeros at the bottom. These are our vertical asymptotes. So the 0 on bottom, I have 1 minus x equals 0. So when I move over x, x equals 1. So my vertical asymptote, the thing that I cannot have, is at 1. Again, tempting to draw a straight line. That was pretty decent. I'm pretty happy about that. Oh. Talk too soon. And up. Okay. So there's my vertical asymptote. Step 5 is to find our horizontal asymptote. Notice that the powers are the exact same. This is to the first power, that's to the first power. So therefore, just my leading coefficients, or the numbers in front of those, make my horizontal asymptote of negative 3 over negative 1, which reduces to 3. So at 3, I have a horizontal asymptote. Dot, 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 dot. Come on, come on. Get a good, oh, almost. It's not too bad. I'm happy with it. And step 6, plot some points. On this side, I pretty much know what's going to happen. If you want to, you can plot an extra point just to make sure something crazy doesn't happen and it doesn't cross over our horizontal asymptote. But I have no clue what's going to happen up here or if it's going to be down here. No idea. Okay, we don't really know ever. So again, I'm just going to make a little XY chart, my T chart, and pick some points. So say that I choose, let's do 2. It's on that side of the vertical asymptote. So if I put in a 2, 1 minus 3 times 2 is 1 minus 6, so I have negative 5 over 1 minus 2 is negative 2, so over negative 1, so it equals 5. So I have the point 2, 5. So probably it's going to be up here, but I'm going to take another point just to make sure. I'll pick 4. So say I choose x as 4. 1 minus 3 times 4 is 1 minus 12, which is negative 11, over 1 minus 4 is negative 3, so I have 11 thirds, which is about 3.6. So I have 2 and 3.6, or 4 and 3.6, so it's somewhere in there. So yeah, it looks like it's going to go up towards that asymptote and go out towards that asymptote. And there's our graph. So for the asymptotes, I'm not going to write it out again. I have x equals 1 and y equals 3. Don't forget the x is your vertical, the y is your horizontal. Is this in continuous? No, because I had to lift up my pencil to draw. It's not one smooth line the whole way, so no. The domain goes all the way up until 1, then it hits a break, and then it continues again. So I have from negative infinity to 1, and then from 1 to infinity. Don't forget I put parentheses around these things because 1 is not included in our domain. Okay, this last example I'm going to look at in this video. In this case, we have x squared minus 2x minus 8 over x squared minus 9. First step again is to simplify. Like I said, simplifying can be something that just makes our problem easier for ourselves. So what I'm going to go ahead and do is just factor the top and bottom, just so that when we were looking for the x-intercepts and the vertical asymptote and things like that, it makes our life so much easier. So I know I have x and x. They multiply to be negative, so they have to be different signs. They multiply to be 8. Their difference is 2. It has to be 4 and 2. So minus 4 plus 2. On the bottom, I notice that I have a difference of squares. So I have plus 3, minus 3, and there it is simplified. It's going to be so much easier to work with it like this. It is f of x equals this. So for step 2, I want to plot f of 0. Well, if I put in 0 for all of my x's, then I have 2 times negative 4. So f of 0 is negative 8 over 3 times negative 3 is negative 9. So I have 8 over 9, which is my y-intercept. It is 0, 8 over 9, so really close to 1, but not quite 1, so I'm going to say, yeah, about right there. How about that? That's pretty close. Oh, don't bug me now, teachers.
Come to D102. Jose, please come to D102.
Don't do it, Jose, it's a trap. Maybe. I might have set it up, but I don't know. Anyways, our third step is find the zeros of the top, which are going to give us our x-intercepts. Well, negative 2 and 4. So x equals negative 2 and 4. Well, I'm glad that I simplified that, because that took 2 seconds, whereas before it would have taken a lot longer. So I have negative 2, I have 4, so I'm going to cross my x-axis in there. So let's see, let's make it a little bit bigger though. Step 4 was to find the zeros of the bottom. Those are going to be our vertical asymptotes. So x equals negative 3 and x equals 3. So we're going to have 2 vertical asymptotes. How cool is that? So at 3, if I can do a straight line, almost, yeah, there we go. And 3, maybe, that's pretty cool. Come on, there we go. That's as good as I got for you guys now. Step 5, find and sketch the horizontal asymptote. Notice our power is the same. Our coefficients are 1 and 1, so 1 over 1 is 1, so y equals 1 is my horizontal asymptote. So at 1, I have a horizontal asymptote. And there's everything that we have so far. This is a funky one, huh? So, looking at my chart, see where these points actually go. I have something in here happens every now and then. You may get something that goes like this, and for whatever reason it goes up, and it crosses that horizontal asymptote. We can cross horizontal asymptotes sometimes, and weird things happen. Okay, but not in this case. Well, maybe. So, if I pick an x, say like 2, if I want to see what 2 is, then 2 plus 2 is 4 times negative 2. So 4 times negative 2 is negative 8. 5 times negative 1 is negative 5. So this is 8/5. And 8/5 is, oh, look at that. It does do that. It's a little more than 1. Cool. So we have 8/5 is right around there somewhere. So yeah, this thing is going to actually cross our horizontal asymptote in the middle and go down that way. So we have this kind of funky looking function over here. Kind of neat. I kind of like that. So now this side will probably be down here. This side will most likely be down here, but we really don't know. So let's choose like -5 and -4. And so if I have -4, I've already done this before, it's 2 2/9. Remember, you just plug it in points. If I do, say, like -9, then it's going to be 1 1/8. So -9 is a little bit more than 1, so -9. So now I'm glad I did this, because this one's actually going to be up here, it looks like. And -4 is 2 2/9. So there's that part. And the other part, make another little short XY chart. I can pick the points, say like 8, since I already have another point over here. I just want to make sure it doesn't cross that asymptote and do something weird. So if I choose 8, 8 will be 8 over 11 after you do the math. So I have 8 and 8/11, which is a little less than 1. So it's going to come down and go down like that and get closer and closer to the asymptote over here. That's all I have for you guys in this video. Sorry it was kind of a long one. Hopefully it was helpful. I will see you in class, and my next video is going to be all about slant asymptotes, because they are amazing. We love slant asymptotes. Okay, have a good night, and thank you again for watching very much.